In this video, we're going to go over some practice problems from our textbook on the material covered this week. So it's going to be sections 2.2 through 2.4. So starting with section 2.2 here, we're looking at the slope of a line. So looking at this first problem, we want to find the slope of the line passing through these 2 points and indicate whether the line falls or rises from left to right. So the first thing that we're going to do here is we're going to write down our slope formula. Lowercase m is going to represent our slope, and we know we can find this by taking the change in our y coordinates divided by the change in our x coordinates. All right, so now we just need to identify what these values are. We have y sub 2, these are subscripts, so this is y subscript 2 and y subscript 1, and so on. So I'm going to call this first ordered pair here x sub 1, y sub 1, and x sub 2, y sub 2. So I'm just calling these guys my first and my second ordered pair here. So we can just plug this directly into our formula. Now, something to note here is that I could have called this my second ordered pair and this my first and kind of switched these guys. If that were the case, I would still plug it into this formula and we get the same answer. And the reason being is because we need to subtract the y values and the x values in the same order. That's all that matters for this formula here. It doesn't necessarily matter what you call them. So using this formula, we're going to plug everything in here. My y2 in this case is -1. And we're going to subtract out our y1, which is 2, divided by x sub 2, which is 4, minus x sub 1, which is -2. So we're minusing a -2. All right, so in the numerator here, -1 minus 2 gives us a -3. And in our denominator, we're going to have 4 minus a -2, so that'll give us a +6. And this is 1/2. So this is our slope here. Now, in this case, the slope is negative. So the slope is negative. So this tells us that the line is going to fall from left to right. So the line falls. Now, this is because if we have a positive slope, that'll indicate that the line slants up or rises from left to right. And if we have a negative slope, this line is going to fall from left to right. Now, like I was saying before, what we could do, let's say I called this one x sub 2, y sub 2, and this one x sub 1, y sub 1. If I were to flip the order of these guys, it's not going to change the value of my slope as long as I still subtract our x and y values in the same order. So in this case, if y2 is 2 here, I'm going to have this guy, and I'm going to subtract out y1. So I'm going to subtract out a -1 and then divide by the change in my x coordinates. In this case, my x sub 2 is -2. And then we're going to subtract out x sub 1, which is going to give us 4. Doing so in the numerator here, we're going to get 2 plus 3, which is going to give us a +3. And in the denominator, we're going to have -2 minus 4, which is going to give us a -6, which is still -1/2. So this is what we mean when we say it doesn't matter in which way that you label these guys, but it does matter in which way that you subtract our x and y values. All right, so for the next two examples here, we want to find the slope of the lines given and sketch its graph. So for question 56 here, we're given an equation of a line and we need to find the slope and sketch its graph. So just looking at this, we don't know what the slope is and we're not given any other information. But we know from the last problem that we can easily find the slope of a line if we're given 2 points. So what we're going to do in this case is find 2 points. Now, the easiest way to do that in this case is going to be to find our x and y intercept. Now, these are the points that intersect the x and y axis. So if I want to find the x-intercept, we know that what we have to do is set y equal to 0. Because our x-intercept intersects this x-axis, meaning our y value is 0. We're not moving vertically at all along this axis. So if we make that our condition, if we set y equal to 0, let's see what our x value is. Doing that, we're going to have x plus 3 times 0, since we're letting y be equal to 0. This is equal to -6. This tells us that x is equal to -6. So since x is equal to -6 and y is equal to 0, our coordinate then, or our ordered pair, is -6, 0. Now we'll do the same thing for our y-intercept. In this case, this point is going to intersect this axis, meaning we're not going to move in this horizontal direction at all, so our x value is going to be 0. So we're going to set x equal to 0 and see what our corresponding y value is. So plugging 0 into this equation here, we're going to have 0 plus 3 times y is equal to negative 6. Now we just have 0 plus 3y is equal to negative 6. So to completely solve for this y, we're just going to divide both sides by 3 here. All right, so this tells us that y is going to be negative 2. So our ordered pair then is going to be 0 since we set x equal to 0, comma, negative 2. Now, by finding these x and y intercepts here, we can plot them on this graph and we can find our slope. So first, let's plot these guys. We have negative 6 comma 0. So I'm going to move 6 units to the left on our x-axis, and we're not going to move in the vertical direction at all since y is 0. So that's our first point. Now, our second point here is going to be 0 comma negative 2. So we're not going to move at all on this axis, but we're going to move down to negative 2 here. All right, so now we have 2 points. We can easily just connect these dots and get our line. We know that all we need is 2 points to graph a line. But just to make sure that we are moving correctly, and we also want to figure out what the slope is too. So what we need to do with these 2 points that we found is label them and find our slope. So again, we know that n is going to be the difference between our y values divided by the difference between our x values. So if this is y2, this is going to be negative 2 minus y1, which is going to be 0, divided by x sub 2, which is 0, minus x sub 1, which is negative 6. So we're minusing a negative 6. Doing so, we're just going to get negative 2 in our numerator here. And in our denominator here, we're going to have 0 minus a negative 6. So that'll give us a positive 6. And reducing this is going to give us a negative 1/3. So this means our slope is negative 1/3. Remember, our slope is our rise over our run. So this is going to help us be able to plot this a little bit easier. And I'll show you what I mean in a second. If our slope is negative 1/3, this means we're going to go up 1 unit, and then we're going to go 3 units to the left to account for that negative. So this will be another point on our line then. Repeating this process from this point, this is our rise, which is 1, and we're going to go over 3 units to the left to correspond for that negative, and this is our other point here. So that's perfect. These are the two values that we found originally. Now, if we want to find a couple more points on the line, maybe in this direction here, we're still going to we're still going to have this rise over run here, but to account for this negative, what we're going to do then is we're going to go down 1 and then over 3. So this will be another point here. Okay, and going down 1 is going to account for that negative because in this case, now we're going 3 units to the right, which would be in the positive direction. Okay, so from here, we can just connect our points, and this will be a sketch of our graph given just this equation here. Okay, so for this next problem here, we're given a little more information. We're given a point and the slope. So with this information, we can sketch the graph. So the slope is 3, and we have this point negative 1 comma negative 2. So what we're going to do is plot this point here, so negative 1 comma negative 2, and then we're going to use the slope to figure out more points on this line. If our slope is 3, this means our rise over our run is going to be 3 over 1. So from this point then, we're going to rise 3 units, and then we're going to go 1 unit to the right here, since this is a positive value. So we're going to go up 1, 2, 3, and then over 1. That's going to be our next point. And then we'll go up 1, 2, 3, over 1 for another point there. So the line is going to look something like this. All right, so that one is a little simpler. We're given a little more information. Let's look at this next question here. So in this case, we're given two different equations, and we want to find the slope of each line and determine whether these two lines are parallel, perpendicular, or neither. Now, in order to determine this, we need to find the slopes of these lines. And the reason being is because if two lines are parallel, then they're going to have the same slope. If two lines are perpendicular, they're going to have opposite reciprocals for the slope. Okay, so if we find the slope of these lines, we can figure out if they're going to be parallel, perpendicular, or neither, meaning none of these cases apply. So, looking at these equations here, there's a couple different ways that we could find the slope. We could repeat the process that we saw in this example here, where we find the x and y intercepts and use these as the 2 points in our slope formula. But for this problem, we instead are going to use our slope-intercept form. So this is y is equal to mx plus b. When we have equations in this form, our m, or our coefficient for our x variable, is going to be our slope. And this b value here is going to be the y coordinate for our y-intercept. Okay, so what we want to do then is we want to get these equations in this form here. We want to completely solve for y, and then we'll be able to see what the slope for each one is. So let's do some color coding here. Let's do this first equation in green. We're going to solve for y to get our slope. So we have 4x plus y is equal to 0. We want to completely isolate y. We'll move this 4x term to the other side of our equation. We're going to get that y is equal to 0 minus 4x, so that'll just give us minus 4x. So in this case, the coefficient of our x variable is negative 4. We take that sign with us. So the slope is going to be negative 4. Now, just a side note here, we don't have any other constant here, so this b value is going to be 0, meaning our y-intercept, or the y-coordinate for our y-intercept, is going to be 0. So we have our slope for our first equation. For our second one, we have 2y is equal to 8x minus 1. And we want to do the same thing. We want to get y completely isolated. So to do that, we're going to divide by 2 on both sides of our equation. This is going to give us y by itself. And then over here, this 2 is dividing both of these terms. So it's going to be 8x divided by 2 and negative 1 divided by 2. Now we can simplify this a little bit further. 8x divided by 2, we can simplify these values. That's going to give us 4 times x, and then we still have this minus 1/2 there. Now notice the coefficient of our x variable is 4, so that means the slope of this guy is going to be positive 4. Now notice the slope of this first line is negative 4, and the slope of this one is positive 4, so these do have opposite signs, but they're not reciprocals of each other, right? A reciprocal of 4 is going to be 1 over 4. So in this case, these guys are neither parallel nor perpendicular. They don't have the same slope, um, but they do have opposite signs, but they're not reciprocals. So I'll write that here. So we do have that the slopes are opposite signs, but they're not reciprocals. All right, so just for added context here, the opposite reciprocal of negative 4 would be a positive value, since we need to have the opposite sign, and we know the reciprocal of 4 is 1 over 4. And then similarly for this guy, the opposite reciprocal of this is going to have a negative value, since this is positive. We need that opposite sign, and we know the reciprocal of 4 is 1 over 4. All right, so that's just for added context here, but in this case, these guys are neither parallel nor perpendicular. All right, so for this last question in section 2.2, we're looking at average rate of change, or in other words, the slope. So for this question here, we're told that the average price of a movie ticket in 2012 was $7.96. In 2022, the average price was $9.17. Find and interpret the average rate of change in the price of a movie ticket per year to the nearest cent. Okay, so we know we're looking at the average rate of change, or the slope. So what we can do is we can apply our slope formula. So the slope formula applied to any 2 points on a line is going to give the average rate of change in y per unit change in x. So for example, if we go back up to these guys here, when we were graphing these lines here, when we were looking at the slope, we were looking at this change in y per unit change in x. So for example, if we were to look at this point here, if we were to move 1 unit in this direction here, so changing our x value, what happens to our y value in return? Well, what happens is this point is going to move 3 units up. So for every unit change in x, every time we move x, our y value is going to move 3 units up. This is because our X value is going to be our independent variable and our Y value is dependent. So our Y value or our output is dependent on what happens to our X value or our input. So same idea here when we're looking at rates of change. We want to see the average change in our cost per unit change in our X value or per year in this case. So what we're going to do then is we're going to create our ordered pairs. We're going to create the 2 points on the line with the given information. We're going to treat our year as our input variable and our cost as our output variable. So we're going to create our ordered pairs. Our first ordered pair is going to be the year of 2012, and our output or our cost of the movie ticket that year is going to be $7.96. And then our second ordered pair is going to be 2022 and $9.17. Okay, so with this information, we can easily find our slope or our rate of change. I'm going to label this as x1, y1, and then x2 and y2, and go ahead and plug it into our slope formula. This formula is the change in our y values over the change in our x values. So y2 in this case is going to be $9.17. Y1 is 7.96. And in our denominator here, we're going to have the change in our x coordinates. So 2022 minus 2012. All right, so in the numerator, we're going to get 121, and in our denominator, we're going to get 10. So this tells us our slope is 0.121. Now, going back into the context of this problem, what this means is that the price of a movie ticket is going to be increasing since we have a positive value by an average of 12 cents per year from 2012 to 2022. All right, so I'll go ahead and write a little blurb about that here. Okay, so here's our little blurb. Like I said, the price of a movie ticket increased by an average of 12 cents per year from 2012 to 2022. So this is just the average every single year. Okay, so this brings us to section 2.3 here. Let's look at problem 20. We want to write an equation in slope-intercept form. So this is going to be y is equal to mx plus b because we have our slope and we have our intercept. So this is slope-intercept form. So you want to write an equation in this form of the line that satisfies the given conditions here. These conditions are the slope is going to be -1 and the y-intercept is going to be 0, comma, -3. So again, using y is equal to mx plus b, we know that our m is going to be our slope. So we're going to have -1 for that guy. We're still going to have x here, and we're going to add the y coordinate of our y-intercept. The y coordinate here is -3. So we're adding a -3 here. Okay, so let's simplify this a little bit further. We know that whenever we have a one coefficient in front of our variable, we don't actually have to write that one. So we're just going to leave this as a negative x here. The 1 is implied. And then we're adding a -3. So this is the same thing as just subtracting 3. So this would be the equation for our line that satisfies these two conditions here. All right. For the next question, we're going to do something similar. We're given this equation and we want to do a couple things with it. First, we're going to write the equation in slope-intercept form, give the slope of this line, give the y-intercept, and graph the line. So once we write the equation in slope-intercept form, we're easily going to be able to answer B and C. So let's go ahead and do that here. Our equation is 7x minus 3y is equal to 3. Now, if we want to write this equation in slope-intercept form, like we saw in question 20 here, we need to completely isolate y. We need to get it in this form. So the first thing that I'm going to do then is I'm going to move this x term over to the other side of our equation. So I'm going to subtract 7x on both sides. This is going to give me minus 3y by itself on the left-hand side, and then I'm going to have 3 minus 7x on the right-hand side. Next, I'm going to divide both sides of the equation by -3 because, again, we want to completely isolate y, and these guys are going to cancel. Doing so, I'm going to get y by itself on the left-hand side. Now, on the right-hand side, this -3 is dividing this guy and this guy. So let's go ahead and separate that. We're going to have 3 divided by -3. and then we're subtracting 7x divided by -3. So let's go ahead and simplify this. We know that 3 divided by -3 is going to give us a -1. And then we have -7 over x, or 7 times x divided by -3. So this negative and this negative is going to cancel. We're going to get a positive. So we're going to plus 7 over 3x. And then lastly, just to get it in this form of y is equal to mx plus b, we're going to rearrange these two terms. So the term with our x value is going to come first. We're going to have 7 over 3 times x minus 1. Now that we've written it this way, we have it exactly in slope and intercept form. So this brings us to part B and C of this problem. Let's actually do part B up here. Just by looking at this equation, we know exactly what our slope is going to be. It's the coefficient of our x variable. So our slope is going to be 7 over 3. And then similarly, our y-intercept is given by this equation here. We know that it's going to be this b value here. So our y-intercept then is going to be 0, comma, -1. Remember, our y-intercept is always going to have 0 for the x value, and then it's going to be whatever this guy is, in this case, a -1. So with this information, we can complete part D of this problem. We need to graph this line. So the first thing that I'm going to do is I'm going to plot this y-intercept here. We have 0, comma, -1, so it's going to be this point here. And then we're going to use the fact that our slope, if you remember, is rise over run. So from this y-intercept here, we're going to rise 7 units and then move horizontally 3 units. So we're going to go up 1, 2, 3, 4, 5, 6, 7, and then over 3. Yeah, so that would be our next point on this line. Now, if we wanted to do a point in this direction here, we're just going to go in the opposite order here. We're going to go over 3 and then down 7. This is going to give us this point here. And so connecting these dots is going to give us this line. Let's draw that a little bit nicer, make sure it passes through all of these points. All right, so that is how we would graph this line here, given just the equation, and identify the slope and y-intercept. For this next question here, we want to write an equation of the line passing through these 2 points and give our final answer in standard form. Now, first of all, standard form is defined as this here: ax plus by is equal to c, where a, b, and c are going to be integers. So these are not going to be fractions or decimals. Okay, so just keep that in mind. First, we need to find an equation of the line passing through these points and then rewrite it in our standard form. Now, the first thing that we're going to do is find our slope. So we have these 2 points here. Let's identify them as x1, y1, and x2, y2. With this information, we can find our slope, which we know is going to be y2 minus y1. So this is going to be 5 minus 1 over x2 minus x1. So this is going to give us 4 over -8, which gives us -1/2. Now notice, just by finding the slope, we can now find the equation for our line. We have our slope and we have 2 points, but we really only need one to use point slope form. Now point slope form is y minus y1 is equal to m times x minus x1. Now the coordinates for y1 and x1 can be either one of these points that we have. So let's let x sub 1, y sub 1 be equal to, let's choose 6 comma 1. Now we can choose this point if we wanted to as well. We would end up with the same answer, but usually you might want to pick points that'll be a little bit easier. Since we have this negative value here, it might give us, or we might have to do a couple more steps, okay? So we're going to pick this point here, and what we need to do is we need to plug this point into our x sub 1 and our y sub 1, and in the same breath, we're going to plug this slope value into our m. Doing so, we're still going to have this y here. We're going to subtract out our y1, which we said was 1 here. This is going to equal our slope, which is -1/2 times x minus x1, which we said was 6. All right, so from here, we need to distribute and simplify and then get everything into this form. So we have y minus 1 on the left-hand side. On the right-hand side, I'm going to distribute this -1/2 to everything in our parentheses here. We're going to distribute this. We're going to get negative 1/2 times x, which is just going to give us negative 1/2 times x. And then when we multiply negative 1/2 times negative 6, first of all, that's going to be a positive value. So we're going to write that there. And then 1/2 times 6 is the same thing as 6 divided by 2. So this is just going to give us 3. All right, now from here, let's move some things around. Going back to our standard form, notice that all our variable terms are on one side and our constant terms are on the other. So what we're going to do then is move this variable term over here and then move this constant term over there in the same step. So I'm going to add 1/2 x to both sides of this equation. And in the same step, I'm going to add 1 to both sides. Doing that, this guy cancels here and this guy cancels there. All right, so this is going to give us, we're going to have 1/2 x plus y is equal to 4, since we have this 3 plus 1 here. So now we're getting close to our standard form. Notice we have our x and y's on one side of our equation and our constant value on the other. The only thing though is that, remember, these values are not going to be decimals. This a, b, and c, these are going to be integer values. So what we need to do is we need to get rid of this fraction, this decimal value corresponding to a here. Now to do that, what we can do is just multiply both sides of this equation by 2. Doing that, these guys are going to cancel. So let's move this over here. These guys are going to cancel, so we're just going to be left with x, and the coefficient is going to be 1. This 2 needs to be distributed to this y, so we're going to get 2y. And then on the right-hand side, we're going to get 4 times 2, which gives us 8. So this is the equation of the line that's passing through these 2 points in standard form. Now, if the question didn't ask us to give our final answer in standard form, we could have, from this step here, just isolated y and then got it in y is equal to mx plus b, or point slope form. Okay, so just pay attention to what the question asks. All right, let's look at this last question here. 77. We want to write an equation of the line passing through this point here, and we want it to be perpendicular to this guy. And we're going to give our final answer in slope-intercept form. Okay, so the first thing to note here is that if we want an equation to be perpendicular to this, it needs to have the opposite reciprocal slope. So the first thing that we need to find is this slope. Okay, so going back to this equation here, we can easily find the slope if we get it in point slope form. So let's do that over here. We have 2x minus y is equal to 7. Getting it in point slope form, we're going to subtract 2x on both sides. This will give me minus 2x plus 7 on the right-hand side. I just switched these terms here so that we have our x value coming first. All right, now we haven't completely isolated y though. We still have this negative sign in front of it, so we can divide both sides by -1 to get rid of that. Doing so, we're going to get y by itself on the left-hand side. On the right-hand side, dividing by this -1 is just going to change the sign of these two terms. So this guy's going to become positive and this guy's going to become negative. So we're going to have 2x minus 7. And just from this, we can easily see that our slope value is then 2. Now, going back to this perpendicular aspect here, if the slope of this line is 2, and we want to create a new line that is perpendicular to this one, that new line is going to have slope that is an opposite reciprocal of 2. So we're going to have a negative value that's going to give us the opposite sign, and then the reciprocal of 2 is 1/2. So essentially, we need to create or write an equation of a line that passing through this point and is perpendicular. So it is going to have this slope. So with this information, we can create an equation using our point slope form. We have a point and we have a slope. So our point is 8,5 and our slope is -1/2. And we're going to plug it into this equation here, which is our point slope form. Now, in this case, our point then, like we saw in the last example, is going to be 8,5. These are going to be our values for our y sub 1 and our x sub 1. So let's plug these guys in. Our y coordinate here is 5. So it's going to be substituted in for y1. Our slope is -1/2. and then our x sub 1 is 8. Now from here, let's distribute and move some things around. We're still going to have this y minus 5 here on the left-hand side, but when we distribute this negative 1/2, this negative 1/2 is going to multiply x and negative 8. So just like we saw in the last example, we're going to get negative 1/2 x, and then multiplying these two negatives is going to give us a positive value, and 8 times 1/2 is 8 divided by 2, which gives us 4. Now, lastly, we're going to write this in slope-intercept form. So what we need to do is get y completely by itself. We'll do that by adding 5 to both sides of this equation. Our final answer is then going to be negative 1/2 x, that's going to be our slope, plus 9, which is our intercept. So this would be our final answer here. This is the equation of the line that's going to pass through this point and is going to have slope equal to this, which will make it perpendicular to this line here. Now, for this last question in section 2.3, we're looking at the total sales of e-readers in the United States in millions of dollars, shown in this graph here. Now, the year 2018 is going to correspond to x is equal to 0. So here is our year on the horizontal or the x-axis. And so at this point here, this is the year 2018, this is 2019, and so on. So using this graph, we are going to answer some questions here. We want to use the ordered pairs on this graph here to write an equation that models this data. We're going to interpret the slope in the context of this problem. So these ordered pairs here, we have this one, and let's go ahead and label them. I'm going to call my first ordered pair x1, y1. This is going to be 0, comma 393. Then my second ordered pair x2, y2 is going to be this guy, 3, comma 294. Okay, so what this is saying then is that in year 2018, since x is equal to 0 here, the total sales in e-readers was 393 million. All right, so we're going to use these ordered pairs here to write an equation. So we're going to use them first to find our slope. So using our slope formula, we are going to take the difference in our output and our y values here. We're going to take y2 minus y1. So 294 minus 393. And then in our denominator, we're going to take the difference in our x values. So 3 minus 0. Subtracting these guys in the numerator, we're going to get negative 99. And in the denominator, we're going to get 3. So this is going to give us negative 33. So with this information, we can easily write an equation. Using our slope-intercept form, we know our slope is negative 33, and then our intercept is going to be this guy, because here our x value is 0. So on the y-axis, we have this y-intercept of 393. All right, now we also want to interpret the slope in the context of this problem. Now remember, in these word problems, in these real world problems, when our slope is going to represent the rate of change. So what's happening then is that this is the rate of change of e-reader sales in the United States from year 2018 to 2021. Okay, so that's what we'll write here. So the sales of these e-readers has decreased by roughly 33 million every year. From 2018, so when x is equal to 0 to x is equal to 3. So from 2018 to 2021. So that is the average rate of change in these e-reader sales. And then notice here that this change is decreasing. So, and that is also indicated in the sign of our slope here. Since our slope is negative, this is decreasing. And we can also see that in this line here, since it's falling from left to right. All right, now for part B, we want to use this equation that we found in part A to approximate the expected sales of e-readers in the United States in 2022. So we can approximate this using this equation here. All we need to do is plug in a value for X, that will be our year, and see what our corresponding output, our cost will be. All right, or the sales. So in this case, our X value is going to be 4. Because remember, if x is equal to 0, that's going to correspond to 2018. So this is 2019, 2020, 2021. So 2022 is going to be x is equal to 4. So we're just going to plug in this value for 4 into our equation. So we're going to have negative 33 times 4 plus 393. This is going to give us 261 million. So this means e-reader sales were roughly or about 260 million in 2022. All right, now as you can see, this corresponds with our graph as well because over time, the amount of e-reader sales is decreasing. So just in the context of this problem, whenever we're solving problems like this, it is a good idea to go back to the overall problem and make sure that our answers are making sense in the context of the problem. All right, so for the last section in this video, we're switching gears a little bit. We're going to be looking at linear inequalities in two variables. So for these two problems here, we want to graph each inequality. So for this first one, we have y is less than 1/2 x plus 3. So whenever we're graphing inequalities, the first thing that we want to do is find our boundary. And our boundary is going to be given by the solid line for this equation, meaning we're going to change this inequality symbol to an equal sign, and we'll see why in a minute. So we're going to set y is equal to 1/2 x plus 3. This is going to be our boundary. Now notice this equation is in slope-intercept form. So now that we have an equation in slope-intercept form, we can easily plot this line. We know that our y-intercept is going to be 0, comma, positive 3. So we're going to draw a point there. And then our slope is 1/2. So we're going to go up 1 over 2. So up 1 over 2, up 1 over 2. And in the opposite direction, we're going to have this. So that's what the graph of our line looks like. And that's why we're setting up this boundary first, just so that we can easily plot this line. Now, whenever we're graphing inequalities, we're going to look at this symbol. Just like we saw in the last video, if we have a less than symbol or a greater than symbol, we're not actually including those solution values in our solution set. So we indicated this with a parenthesis. Whereas if we have a greater than or equal to or a less than or equal to sign, we indicate that we're including those solution values in our solution set with a bracket. Same idea here, but when we're graphing these inequalities, if we're not including certain values, or in this case, the values on this line in our solution set, we're going to indicate that with a dashed line. So this means that anything on this dashed line is not included in our solution set. Okay. Now, next, we need to figure out which region of this graph we're going to be shading because y is going to be less than this guy. And you might already be able to tell if y is less than this line, then it's going to be all of our y values that are smaller than these guys. And you would be correct. However, just so we can be 100% sure, what we're going to be doing is the process of picking a test point and just making sure that it satisfies this inequality here. So what I mean is we're going to pick a test point in this region here. We could also pick one in this region, but whatever region we pick, if it's going to end up as a true statement, that's the region we shade. If it's a false statement, then we'll shade the other region. So for this example, let's pick the origin. That's a super easy test point. We're going to let x and y be equal to 0. So we're going to pick the origin. So we're going to plug in 0 for y and for x. Doing so, we're going to end up with 0 is less than 3, which is a true statement. Now, since that's a true statement, that means this point satisfies, and that means everything in this region then is going to satisfy this inequality. You can pick any point, even this guy, plug it into this, and we're going to get a true statement. Now, like I said, anything on this dash line is not included in our solution set. So if you were to pick, for example, this point, which is right on this line, this should give you a false statement if you plug it in. And so we can test it that way. All right, so indicating that all of our solutions lie in this region, we are going to shade it. And that's it. That's how we would graph this inequality. So let's look at this next question. This guy is similar. We have x plus 3y is greater than or equal to -2. Now, before we start graphing anything, we again want to identify our boundary. Now, our boundary is just going to be x plus 3y is equal to -2, just changing that inequality symbol to an equal sign. Now from here, what we're going to want to do is write this in our slope-intercept form so that we can easily see what our slope and our y-intercept is, so we can easily graph it, just like we saw in the last example. So if I want to write this in slope-intercept form, I'm going to have to isolate y. So the first thing that I'm going to do is I'm going to subtract x on both sides of this equation. I'm going to get 3y is equal to minus x minus 2. And then in my next step, I need to divide both sides of this equation by 3. So we're going to get y by itself when we do that. And then we're going to get negative 1/3 x minus 2/3. Okay, so dividing this guy by 3, that gives us a negative 1/3, and dividing this by 3 gives us a negative 2/3. So that means this is going to be our y-intercept, and this is going to be our slope. So let's use this information to graph this line here. Now, first of all, our y-intercept is going to be 0, comma, negative 2/3. So plotting that, negative 2/3 is going to be maybe somewhere around there. We can eyeball it for this problem. It's not to be perfect. And then our slope is going to be negative 1/3. So we know our line's going to be in this direction. This line is going to be falling from left to right since we have a negative slope. And we're going to go up 1/3. So up 1 would be right around here, and then over 3 would be right there. Up 1/3 gives us another point there. And in the other direction, we're going to go to the right 3 and then down 1 to correspond for that negative value. So our line is going to look something like that. And then in this case, before we plot the line, notice we have a greater than or equal to symbol, meaning our solutions are going to lie on this line. And we're going to indicate that with a solid line versus a dashed line. So the solid line indicates that any of the points on this line will satisfy this inequality here. Now from here, we want to shade the corresponding region. So looking at this guy here, or looking at this inequality, it's maybe not obvious right away which region you're going to shade it. At least it wasn't as obvious as the last example. So in this case, we definitely want to pick a test point. So what I'm going to do then is let's pick a test point on this side. Let's pick 0, 2. That's fairly easy. So for our test point, we're picking 0, negative 2. We're going to plug this into our original inequality here. So x is 0, and then y is negative 2. All right, so on the left-hand side, we're going to get negative 6, and then we're going to get that negative 6 is greater than negative 2, which we know is not a true statement. So this is false. So this means our solutions are not going to be in this region. So our solutions are not in this region. Okay, so this guy does not satisfy our inequality. So that means we're going to shade everything on the opposite side of this line. So that means all of our solutions are going to lay in this region and including everything on this blue line as well. All right, so that's how we would graph these two inequalities. Now, if we want to graph the intersection or union of a pair of inequalities, the process is similar. So let's start with this first question here. We want to graph, in this case, the intersection of these two inequalities. So the word intersection and coincide. These go together, and then we're looking at the union. We're going to be using the terminology or. Okay, so our solutions or our solution set in this case is going to be the intersection of these two. And we'll see that in a moment. Like I said, the process is similar. So what we're going to first do is find our boundaries. And in this case, we have two different inequalities, so we're going to have two boundaries. All right, so our first boundary we know we're going to get just by changing this inequality symbol to an equal sign. So we're going to have 2x minus y is equal to 2. So 2x minus y is equal to 2. And so what we're going to do is just like we saw in the last two examples, let's first write this in slope-intercept form so that we can easily graph this line. So the first thing I'm going to do is subtract 2x on both sides of this equation. I'm going to get this guy here. And the next step is to get y completely alone by dividing both sides of this equation by negative 1. So it's going to change all of the signs of each term here. Doing that, we're going to see that the slope of this is 2, and the y-intercept is 0, negative 2. So with this information, we can easily plot this line. This is our y-intercept, and if our slope is 2, that means our rise is 2 and our run is 1. So we're going to go up 2 over 1, up 2 over 1, and so on. in this direction as well. So our line's going to look like this. And going back to our original inequality here, we have a greater than or equal to sign. So that means our solutions are also going to lay on this boundary, on this line here. So we're going to indicate that with a solid line. All right, now our next boundary, let's do this guy in green here, is going to be changing this to an equal sign. This y is less than 4, we're going to change to y is equal to 4. So we have that and y is equal to 4. So we need to plot this line as well. Now, remember, this is going to be an example of a horizontal line. All of our y values is going to be equal to 4, no matter what our x values is. None of this depends on any x values. So no matter what, y is equal to 4. So our output is always going to be right here. These are going to be all the points on this line, just this horizontal line, y is equal to 4. Now going back to this original inequality, we have y is less than 4, so it's not going to include anything on this line. So we're going to indicate that with this dashed line here. All right. Now, what we need to do is find the intersection of solutions for both of these inequalities. And we can do that by first kind of identifying maybe this first one or the second inequality here. Notice we're saying that y is less than 4. So this guy is going to be everything below this green line here. All of these y values are less than 4. And we can pick any test point in this area and we will see that it'll satisfy this. Now, going back to this inequality, this one's a little trickier. If we look at this line here, we have this in our slope-intercept form. And going back to this inequality, we have a greater than or equal to symbol. So we might think everything's above here, but in this case, it will just be easier to pick a test point, just like we saw in the last examples. So let's go ahead and do that. We already know that y is less than 4 is going to be everything below this green line. So it would be smart to pick something below this green line. So we're not going to pick anything up here. What we need to do is pick something above or below this blue line. So what I'm going to do is I'm going to pick something, let's pick something above this line or below this line, sorry. Let's pick 3 comma 0. This is going to be our test point. Let's do that down here. Okay, so what we're going to do is plug this into our original inequality and make sure that we end up with a true statement. So we had 2 times x, and we said x is 3 minus y, which is 0, is less than, or sorry, is greater than or equal to 2. All right, so we're going to end up with 6 is greater than or equal to 2, which is a true statement. And that test point 3 comma 0 was right here. So that means since we're looking at the intersection of solutions of these two inequalities, we need to shade that corresponding region. So like we said before, all of the solutions for this inequality y is less than 4 is below this green line. And we just showed that all of the solutions for this inequality, this solid blue line, is everything to the right of this. So what we're going to do is shade the intersection of these two regions. This is going to be everything right here. All right, so that would be the intersection of these two regions, and we're going to look at something similar with question 50 here. In this case, we're looking at the union of these two regions. So we're going to be shading everything. Okay, so we're going to repeat the same process. Again, we're going to have two different boundaries. We're going to have this one and this one here. So let's write this down here. Our first boundary is going to be x plus y is equal to 2. And then writing this in our slope-intercept form, we're just going to subtract x on both sides of this equation, and we're going to get that y is completely isolated. So this tells us that our slope is -1 and our intercept is 2. So let's go ahead and plot this. Our intercept is 0, comma 2. Since our slope is -1, we're going to be going up 1 and then to the left 1. That left 1 is going to indicate the negative, and then in this direction here. So our line is going to look like this, and it is going to be a solid line since we have that less than or equal to symbol there. So our solutions are going to lay on this line. Now for our next boundary, again, we're going to do it some different color. We're going to have y is equal to 3. And again, this is going to be a horizontal line, but in this case, we're going to have a solid line since we're going to include everything there, since we have this greater than or equal to symbol. All right, so from here, we need to figure out which regions we're shading. Going back to this easier inequality, we have y is greater than or equal to 3. So that's going to be all of our y values that are bigger than this 3. And that's going to be everything in this region. And again, we can pick a test point and plug it in and make sure that that will be a true statement. So what I'm going to do is shade everything here because remember we're looking at a union of these two inequalities here. So we're going to end up shading everything that satisfies either this one or both. So solutions are going to lie in here because it satisfies at least one of them. Now let's look at this second or this first inequality here. We want to pick a test point. And in this case, let's pick an easy test point. Let's pick this origin here. So let's do this down here. Our test point is going to be the origin. And we're just going to plug this into our original inequality. We had x plus y is less than or equal to 2. So we're going to have x, which is 0, plus y, which is 0, is less than or equal to 2, which is clearly a true statement. So since that test point was right here, that means everything to the left of this blue line is going to satisfy this inequality here. So what we're going to do then is shade everything to the left of this. Now, again, just to emphasize, this is the union of these two inequalities. So what we're saying is everything in green is a solution and everything in blue is a solution. Going back to this first one here, we're looking at the intersection. So we're not looking at the union in this case, we're just looking at where these solutions intersect. So that's why we only shade this region because that's where they do intersect. If we were looking at the union of these guys, we would have shaded this as well. And for this one, if we were just looking at the intersection, if this said and, we would shade everything right here where these two colors overlap. All right, so that is how we would graph the intersection or union of these inequalities.